welcome to Something to Talk About. I'm Linda McNamee, and for the next hour, we are going to find out what exactly is Guildhall and where is it and what, where, why, yeah, all the W's. So, but as always, I would like to, first of all, thank you for tuning in this evening. If you have a suggestion for a future topic, you can always email me at talk@bcattv.org. And as always, I want to thank the crew for this evening. We've had a little scheduling complications over the past couple of weeks, but I do want to thank, oh my gosh, I forgot Jesse's last name. Jesse O'Regan, I think. Oh, Jesse. Sorry, Jess. And Christina Nikitas, who are volunteers who have given up their evening to come hang out at BCAT and help me out. We also have Chris Flaherty, one of the staff members here, making sure us volunteers know everything that they're supposed to be doing. And last but definitely not least, as always, I would like to thank my husband Paul for staying home for daddy date night and playing taxi service or dad Uber, whatever you'd like to call it. So, housekeeping aside, I would now like to introduce Dave Martelli, who is the creative mind, I love that title.
Thank you.
And owner and founder and wearer of many hats at Guildhall.
That's kind of the fun part about starting your own thing is you get to play around and no one can tell you to stop doing it. So yeah. I get to play. And
you get to figure out what your job title is.
Yes, which is constantly evolving, I think, which is what the nature of these things kind of should be.
Right.
Cool.
Cool. Well, thank you. And
thank you for having me here.
I want to thank you for all of the scheduling mishaps. From my perspective, and thank you for still talking to me after all of
I appreciate you having me. This is a great opportunity.
Mishaps. So before we get into Guildhall and your creative mind, I'd like to find out about the rest of you, where you grew up, how you came to the Burlington area, and then we'll talk about how you got interested in the field of technology and where to go from there.
Cool. So again, my name's Dave Martelli. I grew up in Lynn, so right down the street, basically.
Okay.
And through growing up there, I had the opportunity not just to go through the regular public school system there, but also go to Lynn Tech, where I got to learn all sorts of things such as...
Is that like the technical
vocational high school? Yeah, exactly. So, so I got the opportunity...
I don't get out much, so...
Yeah, that's fine. It's a great school, actually. They're doing a bunch of cool stuff there now. But they had the opportunity to teach me a couple of things around computer science, engineering. I got to play with lathes. I got to play with all these cool tools. And from there, I really started getting a passion for things like, oh, what does this computer do that I can make it do? Maybe catch something on fire over there. Whereas in middle school, this is a consistent thing you'll kind of find in this story potentially, is that I'm really good at being very, very bad at things and then figuring it out from there, right? I know, it's the best superpower I can imagine.
I'm really bad at things.
Okay, yeah.
But I haven't figured out that next step yet.
Oh, so as it turns out, just rolling with it and iterating through the process with kind of a bit of a goal, right? So when I was in middle school, I really, really wanted to build a robot that was really scary and could destroy other robots. This is back in 1990s, right? So there was a guy in California called Mark Thorpe that started up a robot war competition, the original one.
Is that the one on like the TV with the
now it is,
BattleBots?
Yes, exactly. BattleBots is the new version. It's in UK. They have it in San Francisco. But Mark started this this basic arena for robots to come in, and they would be able to battle each other, and really tech enthusiasts, people that thought robots are cool, people that thought technology is cool, and they were perfectly fine with the things that they were making catching on fire and blowing up, right? And they would all gather together, and they would, smash buttons, things would catch on fire.
The fire extinguisher.
Yes, exactly. In my studios, we have one in almost every single wall, and a big sign everywhere that says, "Always watch for sparks." But like that freedom to be able to say, without the barrier of the mindset of I have to get everything absolutely right. I have to make sure that it performs perfectly forever and nothing gets messed up on it, right? That idea of I'm building something, I have no idea how it's going to work. It's in a competitive environment, right? Because there's someone's over there built one too, and they want theirs to work just as much as I want mine to work. Yeah. And then we'll just play and see what happens.
But does the competition part get in the way?
Not as much as you'd think. It depends.
Because I don't want to do it if I'm going to lose.
So that's the thing. Everyone that goes to these competitions is more intrigued by the idea of doing the thing than winning or losing, right? So the people that go into these competitions, especially originally in the 90s, there was no one that could help them. So when I went to
Google.
Yeah, there wasn't Google. There was no YouTube, right? And you couldn't go to the library and look up a VHS tape, if anyone remembers what that is, and say, right, a beta tapes, which lost. I'm still a little bitter about that, right? But you couldn't go in and be like, oh, how do I make a combat robot? It didn't exist, right? Yeah. So what it was a bunch of kids and adults. They would go into these hack spaces, or they'd go into their school in my case, right? And I was lucky enough, I went to a middle school in Lynn where I had a metal shop teacher, and I was able to make a deal with them. I showed him this video that I saw. It wasn't actually a video, it was a newsprint ad, but of a bunch of things going on in San Francisco. Right, exactly. I'm trying to like relate it to this generation.
Just check your microphone too, by the way.
Sorry.
It's like pointed right at your neck.
Oh, sorry. I have a big neck, so it helps. Just yell at me if I'm out of thing.
Okay.
Yeah. Okay.
I'm sorry. I love the passion.
Oh, thank you. So so what I did is I convinced my middle school teacher, hey, if I get all of my coursework done for this semester, can I work on an extra project that looks like this? And I showed him like the robot and the things destroying is like, sure, why not, right?
Did you really think you were going to do it, though?
Yeah, I don't know. I don't think the principal did, because I actually got suspended for it.
Oh!
There's nothing more terrifying to a principal than seeing a diabolically smiling, like 11-year-old driving a spike-filled robot with the head of Bill Clinton with a beanie spinning around, right? Nothing scary. He looked at it as like, that's a weapon. You should go home now, right? To his credit, he came back and apologized. So that was lovely.
Although having like spiky things is kind of a weapon.
Yeah, well, it was supposed to be on purpose, right?
Yeah, I know. So like public school thing, you know.
Right, exactly, especially in that environment.
It's a fine line.
But what ended up happening was I happened to have a teacher that was okay with saying, I have no idea how to do this. The teacher didn't.
But let's figure it out together.
Let's figure it out together. And that's how the entire community was. And the people that, even if you've ever seen Mythbusters,
love that show.
Grant Imahara, Jamie and Adam all met at BattleBots. The original Robot Wars, right in San Francisco.
That I didn't
That's
know.
how they knew each other. So Jamie and Adam had this robot called Blendo, which is a walk that was spinning so fast that it would send all of the things flying into the arena. It was so dangerous that the actual competition gave them awards so that they would stop competing, right? And like, how's it? Yeah, exactly, right? And Grant Imahara was one of the robots also there. I can't remember off the top of my head which one he was doing, right? So like, that's how they, they started Mythbusters, right?
Years.
Yeah, it was about 30 years, geez.
No, because the 80s were only 20 years ago, so we're good.
Oh yeah, no, we're good, right, exactly. I'm younger than I look. Thank you. So it inspired this entire idea of, we don't know what we're doing, but we're willing to kind of fail forward towards getting there and seeing what happens, which brings up a lot of resiliency of seeing the things going terribly, terribly wrong, right? So
as long as no one gets hurt.
Yeah, exactly, which also allows you to learn the testing procedures to make sure that no one gets hurt, right? The first time I built my robot in middle school, I accidentally put a little bit too much battery into it, and the battery went kaboom along with all of the motors, right? Ooh. And I looked at it, it was setting on fire, and I was like, that's fascinating, right? Cool. Now I know that maybe I shouldn't stand too close to this and we should have a testing thing, right? And then years later you figure it out, right? But
because Mythbusters wasn't even a show yet.
Right, exactly.
So
Look at how many things,
like the big,
Right. If you the most famous thing on Mythbusters is my eyebrows on fire, right? Do I have any of that left, right? And like, you can see that those guys who are extremely capable, right? That entire team was very, very capable. But their entire process was, let's make a plan. Let's assume that the plan isn't going to work, but let's figure out kind of what we don't know so that we can look for it, right?
Okay.
And start working towards, all right, we'll play around with this because we can't just say we don't know, right? That doesn't help anyone, right? But we'll say, we're not sure what to look for here, so be a little bit careful around this.
Okay.
and we'll test some things and see what happens every now and then.
And then we'll know more.
Exactly. Just like, so engineering is a science. When you do science, it doesn't matter if your prediction was correct or incorrect. You still did science and you're still just as happy, right? So building, engineering, and for competition, same thing. It's the exact same process, right?
Okay.
So by going in that way, you eliminate a lot of the fear of being terribly wrong or not getting it right or not winning or anything like that, because it's about the process more than anything.
Cool.
But yeah.
And you just want your robot to survive, really?
Yes.
You know, it's not about the trophy. It's
fail
just...
so disastrously that it's really cool to watch, right? Every single firework is destined to explode, right? But you want it to explode in the most fascinating and cool way while it does it, right? With style, right?
Style.
Right. It's one thing to fail, it's another thing to fail with amazing brilliance and style.
Go big or go home.
Precisely.
All right. So that kind of answers how you got interested in the field of technology.
Yes. Yep. Mm-hmm.
We had talked about, 1990s being in school.
Mm-hmm.
Before the age of the internet, before, all that kind of stuff. But recently, there seems to be a major focus on STEM, science and science, technology, engineering, and math, or science, STEAM, with
science, technology, art and math. Yep.
Added.
Engineering, art, and math. Yep.
Since your experience was in the public school setting, how did you make that bridge to start working with it outside of the public school setting? Or are we jumping too far ahead?
No. It's actually the main point why I started it. I was extremely lucky, right? I had a teacher that could look at something and say, oh, that would be kind of cool, and be able to have the mentality and the resources to support me, even though he had no idea what it would actually take to support. I mean, some idea, but probably not very much, right? And as I started going over and working in schools, so I taught robotics, a lot of Lego robotics, a lot of regular robotics in public schools for after-school programs. It's just kind of like a fun after my
I kind of jumped from middle school to
I want to buy a company.
So fill me in.
All of this started because the more schools that I taught in, right, including being the head of computer science and engineering for another school, right, the more I felt lucky that I had just the right types of people around me. And the more I realized that how many I was in a fairly small school, and it's small for today's standards, right? And the amount of one-on-one interaction I could get within my shops was fairly good. What if that one guy that helped me wasn't there, and another guy that was overworked because he has a million other things to do, right?
Or was
afraid of blowing something up, right?
Or annoying the principal.
Right, exactly, right? If I didn't have that right, exactly, right? So I felt it was unfair. I was like, okay, my entire life trajectory was based off of those moments, right? And I started teaching around, and I started seeing I would be able to go into places, and kids would consistently say, oh my God, I've never seen this. And parents would come up as like, oh my God, my kid never had the opportunity to try this, right? And now that's all they're talking about, right? From that, I was like, okay, I would hate to be the single point of failure in an incredibly small percentage of people, right? Where there is an entire world of people that could potentially do this. And not just in my own things, right? So that can be true of anything, right? STEM subjects are being approached more in education at the moment, but it's a huge skill and resource drain in order to be able to support them at the level that it really deserves, right? And you can see this where a lot of times budget cuts end up happening within music programs and art programs and stuff like that. Doesn't mean that they're less important. But what it does mean is it's not as testable, it's not as established as a core requirement.
It's not concrete.
Right? It's not concrete, and it's not easy to understand the progressions, right? With technology, because think about it, everything is technology, right? Technically, a hammer is technology. It's really old technology, but it's still technology, right? So having a person that comes in and say, I'm teaching technology, Okay, are you teaching electrical engineering, robotics, machining and CNCing? Are you talking coding? Are you talking drones? Are you talking AI, machine learning? All of these things, right? And there's not enough time in the day, right? And
well, especially with all the standardized testing.
Precisely.
You have to make sure that the kids pass the test.
Yeah, and you have to have measurable metrics of this, right? Not even to mention the confounding problem of like what I know today and will learn today will be at least moderately changed tomorrow. Right. So I got a certification at North Shore Community College for Java Unix, right, which is a programming language and a like Windows, like a computer, a type of computer.
Unix though was like.
It's still being, it's a big thing, big, yeah. So like
mainframe or something,
yes,
isn't it?
Yeah.
Okay,
well, you can also use it for small computers. So like a lot of the maker
I'm sorry, I'm dating myself now.
No. So Unix was the big mainframes things, and then they spawned off Linux, which is the open source that everyone uses.
Okay.
And then it goes back. Actually, Macs for the longest time ran off of a version of Unix called Darwin Unix. So the only reason I know that is because I had to use it when I was in college. But like, Java and Unix, from the couple of years after I learned it, were so different that it was very hard to decipher unless I kept up with it, what it would be, right?
Okay.
And so like when you look at what a school has to provide, how can it, A, keep up to date, especially with standardized testing, right? How can it choose which vector to go towards? Am I going towards machine learning? Am I scared of AI because ChatGPT can make all of your papers be written for you, right? That sort of stuff. And if that's true, which as a business person, I'm okay with, right? It is a financial imperative for me to solve my problems as fast as I can. I don't care. As long as I'm within ethical boundaries, I should solve my problems and get my product out as quick as I can, right? More companies fail because they did not ship soon enough than ones that succeed, right?
Okay.
So like, but from an educational standpoint, I don't want you just ChatGPT writing your ethics, thesis, right? That would not show.
Yeah, that would go into it.
Right?
But yeah, it like. I don't know, right now we have to find that line of encouraging the creativity.
Yes,
and creating the exploration instead of letting artificial intelligence do everything for us. So,
and how do you utilize the tools to be able
the
to
technology
do
is
that?
advancing, but our ethical responsibility is not advancing at the same rate.
Correct, right. And it's...
Does that make
sense? Technology almost... Since the modern industrial revolution, technology has advanced faster than society can keep up with it, because we're, evolutionarily speaking, very slow to adapt, where technology follows a scale that is logarithmic in nature, right? So like it just keeps going up very, very fast. So it takes time to mess around and goof around to figure those things out, right? But
going back to the 90s, everything with cloning technology.
Right, precisely, right? And then you had Dalai Lama and all of those things, right?
Exactly.
How do you stop? And then, not even getting to the international politics of what we choose to do here, they won't necessarily choose the same pathway somewhere else, right?
I know, I digress. That's why I have it down. But
no.
Okay.
But more towards like where STEM for a normal school versus after school, right? It is difficult for schools to make the right choices on what to offer because there are too many right choices, right? If this kid would make a great programmer one day and we can offer him programming, great. If this kid can make a great electrical engineer or robotic, then great. It's hard to universally offer all of those.
Right.
And most of those skills are learned best from people with industry experience. How can you convince a person that's making 3 times as much as they would make in an educational setting to come in and teach, which is, having done both, teaching is a really difficult job, right? It's very rewarding, absolutely rewarding, right?
My brother was the same thing.
But it's a tough
Designed
job.
submarine periscopes for 15 years and then became a high school math teacher.
Yeah. And at that point, even then, like the technology that you used is probably a couple of years old at that point, and you're not seeing the newest stuff, right? So how do you give what's required in that setting while still hitting all your check
And
marks?
it's not just the instructor or the teacher, it's, okay, we need the best computers that can process quickly. We need the tools to build the robots.
There was an article out very recently. It was a bunch of colleges wrote a paper to the government saying we cannot keep up with Google and OpenAI as far as research, because if we combined all of our computing power from all of our universities together, it still wouldn't be enough to compete with OpenAI, right?
Okay.
So they can't even do the research that they're doing in industry right now because the available money funding, all of the equipment that would be required to do it is just completely out of their reach, right? So, which often ends up being the case. The industry has a lot of money if they're doing well in their job, so therefore they put more money into research. Microsoft, Google, all of them do that.
Right.
But it's a big problem. Like even in college, you can't study this stuff depending, at least not the latest version.
Okay, so teaching, you're realizing that schools don't have the resources. So when did you decide to do something about that?
COVID, as so many things happen, right? Great inflection point in history for recently, anyways.
Okay.
Yeah. So before COVID, I was teaching computer science and engineering at a school, and that was full time.
High school?
It was everything from 3-year-old up to high school.
Okay.
So it was all a thing, and I was in charge of making the curriculum and the programming. When they hired me, I was taking a sabbatical from my engineering work just because I'd kind of burnt out a little bit. So I was like, okay.
Corporate America kind of does that too.
Yeah, it does that. And I was just teaching for fun and just kind of living off what I had. And these guys came in, they found me from my previous boss, and they said, hey, would you like to come in, build some makerspaces, and help design our program to be better, right?
Now, did makerspaces exist before then? Because it seems like, okay, I live in a cave, apparently, and it just didn't seem like makerspaces were a thing 10 years ago.
So, excuse me, what you would consider a makerspace has kind of changed a little bit over the years, right?
Okay.
So a lot of times they were called hack spaces before. So the place where Steve Jobs and Wozniak created the Apple computers was a hack space. It was a bunch. It was a group of people in Berkeley just getting together and messing around and so that would technically be a space, right?
Okay.
It's been very popular recently because it's been a place where people can come to use tools they could not afford or maintain themselves, and also be surrounded by like-minded people that are also really interested in those things.
Right.
So you go, you come for the tools and you stay for the community kind of thing.
Got
right?
it. Okay.
And there are some great ones around this area. In Somerville, in the Boston area, there's Artisans Asylum, which is a huge nonprofit. They have Artisans. No, not Artisans Asylum. That's a different club. Maybe looks kind of similar on the inside, but different club.
Thank you for clarifying. Okay, you know.
Right.
I did fall on my head just.
It's good. I talk fast too. I apologize. But Artisans Asylum is a great place where there's just every tool you can imagine. You go in, and there's just all these communities.
Is it like
groups.
through a college or university?
Nope,
or
just a big nonprofit, and it's funded partially by donors, partially by the state now. And they actually have leased out other things just because it became so big.
Okay.
But they've kind of existed. They've started existing in schools more very, very recently. So I'd say maybe 10 years ago, 10, 12 years ago, I started seeing them popping up much more. And partially just to be able to have a space where they can where kids can have more hands-on skill developments with the things that they're thinking about. So it'd be really cool to talk about a boat, right, and like buoyancy and stuff like that. It would be even more interesting if you could have hand-on tactile experience building that boat.
Because a lot of kids are like tactile learners.
Yes, yeah. Learning is best done through play almost universally, and kids are very physical and hands-on. Adults are too, they just kind of stop being it for some reason. But
because it's drilled out of us, it's forced out of us because of society.
Larger problem.
Anyway,
but no, exactly the larger problem, one of the problems I'm trying to solve. But yes, absolutely, you are correct. Yeah, absolutely correct. And that's a can of worms.
So kids need to like.
And what's interesting is before we used to have shop, right?
Yes!
So what they ended up doing is saying, okay, now in middle school, yes, so middle school shop, that's where I learned to build my robot, right? What I really needed was actually at the time a makerspace.
And a shelf.
A shelf?
But anyway.
Yeah, it's better than, so you know those, the pub game, the triangle with the little things?
With the little
that
golf
was my
tees.
favorite. That and I made a machinist hammer in lathe class in machine class. That was really cool. But what they ended up doing was, for some reason, they stopped having shop classes in middle schools and high school, and they kind of ripped those out for, I have
Same
to
reason art
imagine
and music
liability reasons, but who knows, right?
I don't know. Maybe it's the whole thing with art and music and
Exact same thing, defunded and stuff like that. And when those went away, there was a lag for a year or three, and then makerspaces, which were combinations of multiple types of shops, all started coming in, and a lot of them were more automated too. So you have like 3D printers and stuff like that, which are safer and easier to use. They break a little bit more often, but outside of that, they're fun, right? In McNamee, right?
you can now build a house out of a 3D.
Yes, quite literally. Yeah, they have 3D printers with that do concrete and actually build up full houses.
Oh, I thought it was like plastic houses.
They can do that as well. There's right next to our Woburn location, there's a 3D printing place that does only cast metal stuff. So they print out the mold that you then pour the molten metal into, and then you get an engine for a car, or usually it's rocket parts.
Okay.
But yeah, absolutely, all sorts of stuff. It makes sense because then you can just, the limitations of older manufacturing techniques go away when you start using things that can print in thin air, basically, right? So it's really cool. And
like
it's
kind of like Iron Man and the whole like.
Precisely, right. And that's like a combination of machines that are milling out things, 3D printing that's bringing stuff up. So additive manufacturing is when I'm adding stuff to a plate, right? Subtracting manufacturing is when I'm taking something and slowly subtracting from it. So like a lathe or a mill or a saw would be that, right? And then
I'm
you
thinking
have
Swiss cheese, but maybe it's
also
just
yes, you can make so if I built up a wedge using a 3D printer, that would be additive, and if I drilled in the holes, that's subtractive. Right? Perfect.
Okay.
And then if you had a robot come over and pick it up and hand it to the mouse, that's pick and place. That's robots that put it all and assemble it all together.
Okay.
Right? Can do it for a Christmas tree if you want to. But so that stuff started becoming more interesting as the technology came in, and then we have more computers and stuff like that, and they'd start learning how to use those tools instead. Where the focus with makerspaces turned away from how to specifically learn how to be a machinist, right, which is what you learn, to how do you learn how to create something using whatever tool is the right one for the job, right? So makerspaces focus less on the specifics of how to run and operate a specific tool, right? If you ever went to a machinist shop in middle school or high school, it was the exact same type of lathe, and everyone sat there cranking out the same hammers, right?
Right.
In a makerspace, you, if done properly, in my opinion, they give you a challenge, right? I need to put that nail into that piece of wood. Don't care how you do it. Make me something that allows me to do that, right? Someone's going to take their friend's hand and go like that. That's not going to work too well, right? Another one might take one of these things, a little bit too soft, and they'll start looking around, right? And there's technically no wrong way to solve this problem. If I can go up to the bandsaw and take a piece of wood and cut it into like a hockey stick and start going tap, 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 that works. If I can take a 3D printer and build out a gigantic Thor's-looking hammer, looks even cooler, still works, right? Or a machinist lathe, any of those.
But it also depends on the material.
Yeah, exactly. And that's a great thing that you can learn, right? So that's a trial by fire type thing of like, I want to 3D print out this hammer. Should I make it out of this kind of plastic or this kind of plastic?
Right.
I don't know.
Or should I go and use wood?
Use wood and do it that way, exactly. And that's where you have the opportunity to say, okay, there's 3 ways I can figure this out. 1, ask the teacher. I don't want to talk to anybody. 2, I can look up the specs and the material specifications for the thing that I'm going to make it out of, right? And there is a good percentage of kids, smaller than the other types, but a good percentage of kids that will nerd out on the impact and Newton force that I can put on this is this much before it cracks, and that's really cool. I wonder if I can do some stuff with that, right?
I can't picture like a 10-year-old doing that, but okay.
We have a kid in one of our locations, Emmett, who decided that he wanted to play musical instrument and decided that he was really interested in the sound itself, right? Not necessarily instrument. So he
Okay.
had a sound he wanted to make, so he figured out all of the acoustic properties of different materials around him and started making an instrument out of his own thing.
Oh, wow.
So yeah, he
Okay.
also developed his own language to then sing in, which sounds really weird. But yes, so there's like some kids
They
really
did
get
it for Star
right?
Trek, but
And like,
yeah,
if you, kids will rise to whatever level that you expect from them, right? No matter how low it is. If you look at that kid and say, hey, this is what my expectations of you are, there's a glass ceiling there that's very hard for them to rise over because that's their expectation.
Okay.
Both from a, I'm lazy because I'm a human and it costs energy, right? So there's an evolutionary reason why
and
that's
you only
true.
expect me to be
Right, you only expect me to be here, check mark, now I can do something else. But if you raise that bar up here, right?
Yeah.
They may not reach that bar, but they'll go higher than that level than they might have previously been stuck at, right?
Okay.
So if you just allow them to say, hey, is this possible? And even if you don't know, you say, sure, why not? I don't know, right? Right, try it, right, and let them really get into the process of trying to figure it out.
Okay.
And when they mess up, give them a bit of encouragement and say, oh, that's cool. I wasn't expecting that to do that. What? How? Why? Why did that happen? How did that happen? Right?
Yeah.
Right. And what? And you engage with them because at first they'll feel bad. It's like, oh, it didn't sound like what I wanted.
Yeah.
It's like, okay, but it sounded like something, didn't it?
Yeah.
Cool.
Okay.
So can you make it sound like something else? I don't know. And then you just figure out where you want to go.
Okay.
Right? So by giving them that opportunity to play, kids are curious by nature.
Okay.
Right. So they'll take that curiosity as long as they're supported. Right. And that's where the testing things tend to take away from that, right? So like if I have a test where I can get a
Like
yes
the
or no,
academic
like
testing.
academic style,
Okay.
right?
Because
So-
I'm like, well, you kind of have to test to see if the hammer breaks, or
Right, right. And there's different ways of doing it, right? So some schools have the ABCD and there's the you got the question right or wrong, right? And that doesn't really make the kid want to take risks because there is a definitive bad that they could do, right?
Right. Okay.
You have other styles of grading these systems like rubrics. I call them KPIs, key performance indicators.
Okay.
Right? So like here is, can I borrow a prop for a second? Okay, cool.
I don't know if they'll like roll away, but okay.
Yep, I'm looking at what
We'll get
I
it
got
later.
here. I got a cool thing.
There's gonna be glitter everywhere.
This is, sweet. I have my KPI for my little droney thingy here is to fly. Ready? I've made this thing. This is my brilliant drone is going to fly. Did it fly? No, not really.
Not really.
Right?
It's falling with style.
Yeah, it followed with style, right?
Yeah, I don't know
I
about
could go
style.
like this. Okay, sweet. It flew. I flung it into the air. It flew. Okay. As the teacher now, I'm starting to think, how do I make this more challenging so I'm not outwitted by a fifth grader, which is pretty often the case of what's going to happen, right? Can fly and maintain its height at for a couple of seconds, right?
Okay.
That's
Kind of
where
like
it
the Wright
starts
brothers'
thinking.
original.
Right, exactly.
Okay.
Right. So now I, as a teacher, start having to think about this and really think it through. Is like, how can a kid game the system, which I'm okay with because that's creativity.
Okay.
Right. And maybe they'll come up with a new solution that's novel that I've never thought of before. And that's really cool.
Yeah.
Right. So how do I make it so that they have a problem to solve, right? And I make sure that they're learning the things I'm hoping they're going to learn. So like if this was a boat instead, should not sink, right? Right. Ideally. And like someone's like, oh, it's sunk, but it comes back up again. You invented a submarine. Good job, right? Cool. Exactly. I didn't even expect you to do that. But not only can it float, it can sink and it can float.
Okay.
Because maybe their thought process, because you can reverse engineer this, right? It's like, all right, the average kid will say, here it floats, right? And the next kid will say, whoop, oh, it dropped. Like, oh, that's not good. I want it to float. I have two ways of solving this. One, I can say, make so it never drops and only floats. And the other one is like, well, it's down there now. Can I make it go from down there to up here? Right?
Okay.
So now I have potential submarine territory. Depends on how creative that kid is, right?
Okay.
So by giving them that opportunity to mess with it and having a grading standard that allows that much flexibility, you'll allow them to be able to come up with new ideas and learn more and understand more, basically, right?
Okay.
Sorry, go ahead. Yep.
With that in mind, my brain is like,
Yep.
how individualized attention are you able to give these kids? Because if you have, 20 kids, like
It's my favorite
in
question.
a school system.
It's my absolute favorite question. So let's go back to how Guild started, right? So first off, Guild is an acronym.
Oh, really?
Yeah, right.
Oh, cool.
It's also a whole lot of
we
words,
kind of
but
like
I
went off
love
on this
acronyms.
tangent. So
Yeah,
let's bring this back.
Yep,
to,
bring it back to Guild.
Okay,
Guild
thank
stands for Guided Universal Intelligent Learning Device.
Oh,
Right?
Okay.
So it came from your exact problem statement, right? How do I handle all of these kids? Even worse, how do I handle teaching all of these kids when they're all remote and I'm looking at them through Zoom, right?
Right. And they're all at different levels.
And all different levels and different grades. So I have like all the way down theoretically from guided with another teacher from like first grade or below, all the way up to 8th grade or whatever I happen to be doing at that time, right? And every single one of them had a different project that was individualized towards them at a different skill level. Some of them were working in partners, some of them were working individually.
Which was my next
Right.
question is, are they working in teams? And if they're
Depends on
working
what
in
they're
teams,
trying to
how do you,
right?
okay.
Generally speaking, I try to have kids working in teams the majority of the time because it's very difficult to do anything at any scale by yourself. So
Well, also like the whole brainstorming factor.
yes, exactly. Yeah, and you'd be stuck in your own creativity and you don't have anything else, right? So what I end up, because my brain was going insane. I was like, oh my God, I got like 150 something kids. How?
All at once.
That's doing that one.
Feel
That's
like
doing
the
that one.
Muppet
That's
Show
doing that one.
because they're
That's
all-
doing that.
yeah.
I'm sitting there. I'm like trying to like write it down and spreadsheet
And then like
it,
one
and I'm
kid,
like,
it does float,
Yeah,
and the other
yeah,
kid
yeah.
it sinks and floats, and you
And-
want to encourage both of them, and now you're like, oh my gosh,
And some of them-
cloning me is not an option.
Right, and like so there are a couple of ways that we figured this out. One is we try to have kind of a consistent wheelhouse where certain groups of kids would be, right?
Okay.
So like we're doing robots. Don't care what your robot does, but let's figure out robots.
Okay.
There'd always be that one kid that says, "I love game development." It's like, okay, can you program a robot controller in your video game that talks with a physical robot? Okay, I can do that. Close enough. Okay, so that's variance, but
Close enough.
it works out, right? What I decided to do during COVID was to try creating a software, right? Because originally I'm a software engineer and a systems
Okay.
engineer, right? So that's my training, anyways.
Okay. Well, I
So-
think we kind of skipped over
Yeah,
that, but that's okay.
I'm not very important, so it doesn't really matter. But
Well, it does, but okay.
hopefully I'm replaceable. Otherwise, everything's doomed. At least in what I'm trying to build. So what I decided in COVID was, okay, I have to manage all of these people, all these kids, right? They're all individualized as much as they possibly can, and I have two different ways that I could go about this. One, I can compartmentalize them all so they're doing the exact same thing, right? That did not flow with my philosophy of learning.
That's what they get in
I
public
want
school,
kids to
right?
be able to go at their own pace because they'll learn better that way. And if someone's
They'll
taking
understand
longer,
it.
they'll understand it, but they'll also play with it, right? So let's say that I did the thing, right? But I'm curious about the thing to the point where I want to do it more so I can understand it better, right? Let's say that I'm making a video game, right? And my video game needs my car to go forward, right?
Okay.
Cool, that's awesome, did that. Next thing on my checklist there might be make it so it crashes when it hits a wall. Okay, that's cool. But I really am intrigued by the speed thing, right? I don't want it to be detrimental to that child to sit there and be curious and want to learn more about that. To say, oh, can I make it so that different cars have different speeds? Can I make it so that there's a ramped curve of how quickly it goes, right? So the Tesla can go 0 to 60 in 2.3 seconds, and the Pinto can go 0 to 60 in 2.3 minutes, right? So like
Downhill.
exactly, down the hill, right? So like I don't want to penalize that, right? Because that's interest, right? And school can be very good at kind of squashing interest in order to make sure that they're hitting benchmarks, right?
Right.
So I want to make sure I'm not doing that. So what we ended up doing was creating a software that would give the kids the opportunity to choose a project, which was set as a problem statement as if you went into a guild, which is a place where a bunch of people of similar job, like a woodworkers guild or machinist guild or something like that. I am an anime fan. I thought of Fairy Tale's Heroes Guild, so they would have a big job board right there. So there's a job board, and they could walk up to the job board and decide what job they wanted to take, right? So this person.
So wait a minute, you created like an entire software?
Entire game, yes.
For this? Oh my gosh,
And
okay.
machine learning model, and we actually tested it across 6 countries. And
Wow,
all 3
okay.
countries. Yeah, I'll get to that in a second. So that was the problem statement, is how do I do this? The only way I could think of it, while gamifying, because gamifying is a thing that people like, so or kids will be more intrigued by, right? So I built a video game called Guild, Guided Universal Intelligent Learning Device. And the entire job on the front end, what the students would see, was say, hey, I walked in and it literally looked like a guild hall. It looked like big, majestic towers and thing. And you can
Big
click on
castle.
the dot, right?
Okay.
There's chat so you can talk amongst other members and stuff like that, right? And they would go in and they would click and select the job that they wanted to do. Like, Mr. Spider wants a new web page, right? So like, right? I tried to be as punny as I could be. I was just a father at this point, so my second daughter was about 2 months away from being born. So I was trying to get my dad jokes as good as I could at that point. But yeah, so you could choose that, or if I'm more into game design, game development. Oh, this guy wants an open world role-playing game where they can be pretend to be a samurai, right? So that they can practice, right? And they would go over and select the job that they'd want, and then there would be a list of KPIs. So for a racing video game, it'd be like, has a world.
Okay.
Looks like something, doesn't matter what it is, but is a cohesive world, right? Has an object in it that I can drive, right?
Okay.
Could go forward, could go up, could go down, I don't care. It's meant to be broad, but it's meant to also be specific, that I can look at it and say, yes or no, does the thing drive? Can I drive it, right? Can I move it and control
Can it move?
Right?
Yeah.
Exactly, right? And then
I control
you can
where it
win or
moves?
lose, right? And that's a whole philosophical debate around that, right? So games can either be win or lose, or never lose, right? So like Flappy Bird is just don't end the game, right? And then they would choose it and go through, and I would grade them based off of how well they met those individual KPIs. And they would be able to send me the work through the web interface.
Okay. Now, was this through Guildhall, or was this?
This is no. This I was developing on my own on the side.
Okay.
This is before Guildhall. So this is just Guild. The software was called Guild. Guildhall came right after this. So Guild ended up being the software that would allow individualization that is tracked, measurable, and
Like the whole SMART goals
the
thing.
whole SMART goals, the whole thing. They could submit work. I could see everything they're doing. I was like, this is interesting. And we're in the middle of COVID, and I and my wife are both very entrepreneurial. So like, let's see if other people. I had built up a team of 5 or 6 other people, depending on the day, that were helping me develop this and stuff like that. So we ended up sending it out to about 6 or 7 different countries and about 4 within the United States, just schools, right? Because we wanted to see how it would work, right?
So you needed the kids, basically.
Yeah, exactly.
Okay.
We needed the teachers to see, because it seemed like it would be interesting, it would be helpful, right?
Okay.
So we learned very, very quickly that even though this tool was here for them, the access to computers and technology, the access to the type of students, language barriers, all those sort of things started becoming slightly an issue. Some of the schools that worked amazingly well, others that didn't, because the system was way too open. There's almost anything you could do with it, right?
Okay.
So Guildhall, after COVID, so I decided not to continue teaching at the school that I was at. They were consolidating things down, and it wasn't
bigger and
aligned with
better
me.
institute.
Exactly, it wasn't aligned with what I was kind of trying to hope to do. And I decided, okay, the problem with this was it's too open-ended. So if we enclave this down into a physical building where I controlled the machinery, I controlled the system, we can start working through the kinks and then expand it out afterwards, right?
Okay.
So iteration, basically. Doing the same thing we asked the kids to do. Did it work? Nope. Okay, change your design a little bit. Does it work now? Nope. Change your design a little bit. That's the business model of this, is every, God, we've iterated on Guildhall. We've been open for 3 years, so we have 3 locations now.
Oh, cool.
And,
wow.
Yeah, Woburn, Cambridge, and Natick is for professional development. And we've started zeroing in on what our members like to do, and we have a full metal shop, CNC lathes, mills, VR with VR treadmills.
Wow.
Like
Okay.
we have a massive facility.
So it's not
recording.
just a little computer thingy.
No. Our
software.
Our Cambridge location is 2 locations, about about 4 times as big as this room.
Wow. Okay.
And higher ceilings. It's in a church building, so it's a massive, really cool looking building. And it's filled with as much stuff. We have jewelry areas, as many things as we could that would be within our wheelhouse of electrical engineering, coding, mechanical engineering, which is just building anything, right? And art and design. So everything from YouTube video creation to drum and bass music editing to 3D printing, 3D design, 2D design, art, pastels, all that sort of stuff. So, and we really started focusing in on what can we do and what can I teach other instructors how to do this methodology. What's cool is really recently we've started partnering with the Boston Public Schools, Boston Libraries. There's an organization called the Ron Burton Training Village, which is a large nonprofit that deals specifically with kids that are in low-income families or don't have as many great outcomes potentially. So kids that really want to try but aren't necessarily in a place where they have the opportunity to. Right. And that's a good 300-400 kids or whatnot, and we partner and we go out to schools with them as well. So it's a great opportunity now for us to go out into every kind of use case, from the really high-end families with electrical engineers and robotics and in their family to kids that don't have a computer at their house, right? And just expand on this educational model to see where it breaks, so that we can make it so it's accessible for everyone. The real motivational part that's happened kind of recently with this, we have a partnership with the Department of State. So we deal with their sports ambassador program. So their sports ambassadors come from Egypt, from France, from all around the world, right? They come here for about a week or two.
Athletics type?
So for some reason we have a large athletic community that comes in, which is cool. I've been a martial arts instructor since I was 12, so I'll take it. But what ended up happening is we had some kids that came in from various countries. They'd go out and they'd do sports and stuff, and then they'd come to us for what they wanted to learn on top of that, such as STEM and engineering. They'd go to other places for culinary or whatever, right? And we had this one girl that came into us. She was 17, and she did robotics with us, right? And she's like, this is absolutely amazing. This is what I've always wanted to learn. I've always wanted to do electrical engineering. It is illegal in my country to be able to learn this.
Wow.
Right. And in my mind, I'm like, how do you solve that problem? Right. So before I was thinking, I have kids in Massachusetts that are like, this kid over here, obviously is in inner city Boston school that has so many kids they can't possibly one-on-one this kid, right? But how is this a global problem? How do we have equity in education that is future-minded? Right, that can make it so that it doesn't matter where you are, right? You have some prospect to be able to go and have a future anywhere that you want to, right? And how do we not limit that because of politics or whatever, right?
That's another episode.
That's where you started a nonprofit off of that one. But that's where Guild is really trying to do is how do we take each individual student, right? Regardless of who they are and where they are, right? And have a system that can figure out exactly what they need, right? Figure out exactly where they should be going based off of their input, based off of their interests and their skills, like what they're actually doing well.
So is this like an after-school type program?
A little bit of everything.
Go into the schools to supplement, or?
So we have one school we're partnering with now. We're running their entire computer science program. We go and have.
So you're more of a consulting company?
No, we send our actual. So we do.
I'm trying to get my.
Yeah, it's difficult for even us. So we have a couple of different types of programs. One, come to us for memberships. If your kid really wants to come in and have a space where they can make anything that they want within our realm of those 4 things, right? I don't have a certified kitchen in this facility. We're working on that. Gastronomy is cool. But yeah, so if you have a kid that wants to learn how to build up stuff, and they are the type of kid that is self-focused and wants to learn and bring themselves up, they don't need a huge amount of direction. But they want to be in an encouraging community so they can learn and bring their own ideas to life. That's our memberships, and we have that in Cambridge and Woburn, right? They can come in and we have full shop and supply. As far as us going out, we have...
Now, when they show up, is it just like, here's a problem, solve it? Or is it like a class type
Every kid that comes in has an interview on their first day. And we have a full process that takes that kid, and we basically say, what is it that you would like to make or do? If you don't have any ideas, we have a whole lot of questions to kind of help that, and we have examples of machines around. But it's like, it could be absolutely anything. My personal project for this is we have a skylight in our Woburn location, right? And I would like to have a satellite in geosynchronous orbit directly above my skylight with a laser pointer that points down into my skylight, and at roughly 7:50, about 10 minutes before cleanup and everything, it just starts blinking cleanup, and every now and then we'll put my logo in there just because it's fancy, right? So
Yeah, but getting a geostationary satellite is
outrageously, so from that project, we can say, okay, that's an amazing project. I think we can do that. I have a colleague that just went up with the Artemis with his school. Why not, right?
Why not?
Do you know how to use a laser pointer? Right? Let's start modularizing. Right? Not in my eyes. Let's modularize this to make it so, because every big problem is comprised of an unknown amount of tiny, very solvable problems. So getting that, reverse engineering your big problem that's making you just sit there and go like,
never gonna happen.
Right? Taking that from there to a workable small program that still keeps you on track, that's a skill in itself, right? So we start teaching that. And then when a kid comes up to us and says, okay, you want to make a satellite, have you made things go up yet? No? Okay, let's try that. Can you make something to go up? Up core 5, sweet. He goes over, and he'll go over and he'll try and make it, and then it'll flop over and they'll come up with us to us and they'll say, it doesn't work. And we'll smile and nod with you and agree. You're right, it doesn't work. Sweet, good observation, that's great, right? And this is the beginning of resiliency training, right?
Okay.
So what doesn't work? What were you trying to do, right? What did it do, right? And then what's the difference is how can we solve the problem, right? How can we figure out the correct question?
Change expectations.
Exactly. Well, not even necessarily change expectations. Change the question you're asking from it doesn't work, right? Because you grew up if you're around in the 90s, we had these things called VCRs, right? And no one except for the one 12-year-old kid on Christmas Day knew how to change the time on the VCR when it would unplug, right? So to go from the
12.
Yeah, precisely, right? Same thing on my microwave now. How do you go from the it doesn't work, right, to it's doing something, that's interesting, what is it doing, and what do I wish it to do? Right. Why is it doing that, right? And then starting to look at the system to learn the system.
How can I
manipulate my environment to make the thing that I want to have happen? Right? Because basically anything is possible. You just have to figure out how to get there, right? We're humans on a gigantic spinning rock flying through space, flying through the universe, right? Everything's weird, man. At this point, you could probably figure it out, right? So how do we get people to start thinking, looking at this problem, why isn't it doing what I want to, and what is it doing and why? They can start asking better questions. When they start asking better questions, it's really easy to find an answer to that, right? And then we train them over time to start looking for better questions, to start finding the answers on their own. And the idea is by the time
not necessarily better questions, but more focused questions.
Yeah, exactly. Yes, more focused questions, questions that can be answered.
Yeah.
Right? So like, if I say something doesn't work, that's not really a question, it's a statement, right? But that's how everyone looks at the VCR and they say, it doesn't work. Okay, that doesn't help you move forward, right? So how do you look at something nuanced enough to say, it's doing this, it is working, just not in the way that I want, right?
Not the way it's supposed to.
Yeah, exactly. So how do we switch that, right? And then we teach that skill. So resiliency, analytical thinking, the ability to look at a problem and look at it from a solutions-based mindset, and then going from there. Everyone has their own project so that they are completely up to them what they're working on. From an instructor standpoint, there's kind of big blobs of like, you're building a robot. There's only so many ways you can build a robot, right? So your robot might be a walking robot that offers you butter so that you can butter your bread. It could be a Baymax robot that comes over and gives you a hug, but they're all kind of the same thing, right?
Or the battle bots,
Or the battle bots, exactly.
Hopefully
It's
the
a ball.
BattleBot-
Instead of a hug, it offers you a whack, right?
Hopefully those two don't meet.
Exactly. They're hugging each other just very aggressively. But yeah, so exactly the same thing. And then hopefully they start learning how to look at the world that is completely full of problems and have that excite them, because then they won't be bored. There's a lot of things to do, right? And like
things to fix.
Yeah, there's a lot of things to fix, right? Like I can look at things
solve.
and say, oh my God, there's so many problems in the world, and I can feel very nihilistic and I can feel overwhelmed by that fact, right? Or I can say, oh my God, there's so many problems, there's so much work to do, right? I have so much purpose in my life now, right? So like, and just driving that in the, there's a saying, you're the culmination of like the 5 people you spend the most time around, right? And someone will say that it's actually interesting, income projections are based off of zip code. So the highest and most accurate tell of how much money you will make as an adult when you're a kid is what zip code you were born into, right? So and yeah, right, weird. So like it actually.
I'm like, where do I want to move?
Right, not LA these days, I heard. But yeah, so because you're surrounded, right? If you're surrounded by a large community of people that do not go out or do not have access to go out and solve problems, you're not going to think that's possible as a child, right? You're calibrated as a kid for you to believe what's possible, right? So as you put people in environments where there's a bunch of people that say, oh, it's just a problem, go and solve it, they'll think that's normal.
It's an opportunity.
Right? It's an opportunity, right?
Yeah.
And like, you want to extrapolate this further out so that it matters for everybody. Every single, like, we have no idea who in their mind has a cure for cancer. We have no idea who in their mind has the next greatest rocket design that makes us interplanetary, right?
But
right?
we need
Any
to
of these
ask the
things,
questions.
Right? Yeah, exactly. If we can provide a way for any of these kids to learn anything that they are passionate to learn about, right? There is a higher percentage chance that somewhere along there, all of the fields start advancing faster. All medicine advances faster. All inner politics advances faster.
But it also seems like, we started this conversation where it was like STEM based.
Yeah.
But it could be
That's why the
anything.
UN Guild is universal. Guided Universal Intelligent Learning Device. I started with STEM because it's what I know the best.
Okay.
And it's also what I was teaching at the moment. Right. It also makes sense to gamify and to STEMify a STEM-based curriculum. Right. But we've tried this, and we're trialing this with language. We're trialing this with psychology. We're currently talking with Southern New Hampshire University to try and figure out accreditation models versus off of this as well. Right? So like the idea is, how do we take it from you happen to have been born here and you're in this system, right, that can give you all of its resources, no matter how much or how low it is, right? How can we make sure that you have access to everything you need to be the best thing that you can possibly be and be the thing that you want to be, and never feel like you're limited by anything, right? At least in being able to learn and move forward, right? And how do we give those access to everyone, right? So STEM is where it starts, and that's where we're going. But yeah, it's
now. Do you have to do like fundraising or grant writing or something? Because I'm like, having all of this material for everybody seems kind of expensive.
Incredibly, yes. So we're fortunate where we run a bunch of businesses in and around education. We do have a nonprofit that's specific. It's called GEA, Global Educational Advancement, and the entire point of that is to help raise funds for programming, schools, teacher training. Massachusetts is great. They have a thing called the Express Grants, where they have teachers can call us and get trained in all of these things for free. They'll be reimbursed completely by the state. So like there's ways that.
Now, do you have to partnership with the state?
Yeah, so we're a registered partner with the state to be able to do that. Yeah. Right. And we're constantly looking for new ways of being able to inject into different vectors of corporate sponsors, as well as things like that. But yeah, it's through all of that.
Because when I first invited you, I thought you were like a freestanding thing, but you're actually like a support system or a scaffolding, I guess.
Yeah.
For like everything.
Yep. We have a full developer team also, where the first that I'm aware of that's using Open Badges 3.0 standards officially for micro-credentialing, and we're working to incorporate with multiple universities to be able to make it so that high school kids can get advanced placement and degrees to encourage them to continue going on to college.
Wow.
Right?
Okay.
All sorts of stuff. Yeah. So.
Well, you know what? I think we're going to have a sequel because we are out of time.
Sorry, I have a tendency
And
of
I'm glad that you
talking a
talk
little
fast.
bit.
Well, no,
Yeah.
I'm also glad that you talk fast, or else we would really have to have a sequel. But anyway, thank you so much.
No, thank you so much
This
for
was
having me
like
come in.
amazing. I'm like all jazzed now. Thinking,
you.
my
I
brain is going
appreciate
in a
that.
million different directions. And I also want to thank everyone at home for tuning in. I hope you have been enthusiastic about problem solving or discovering opportunities to make our world a better place. So thank you very much. Hope you have a wonderful holiday season, and I will see you around town. Good night.